Friends, very good morning to everyone. Today's subject of discussion is retrosynthetic strategy involving CC disconnection. Till now, we have discussed the organic compounds which is having two parts, and those two parts are connected through an heteroatom. For synthesizing this kind of compounds, we break up the molecule adjacent to the heteroatom, and we have seen as CX disconnection approach. Today's subject of discussion is CC disconnection approach. The CC disconnection may be 1, 1 CC disconnection. For example, I take a tertiary butyl alcohol, a tertiary alcohol. This is having a functional group attached to the carbon, and this carbon is again attached to three different carbons. In this case, I break say bond between the carbon and the carbon. Once I break this, one of the synthons will be having electron richness, another will having electron deficient. Here this is a donor synthon and this will be an acceptor synthon. For getting this R minus a donor synthon, I can use Grignard's reagent or MgBr. For getting this acceptor synthon, I can use R1COR2. As we know, alkyl magnesium halide Grignard's reagent, the alkyl carbon is attached to magnesium. As magnesium is more electron rich as a metallic compound, it donates electrons to the R. As it donates electrons to the R, it becomes R minus. R minus combines with the carbonyl carbon, attacks on the positive center, and pi electrons moves on to the oxygen. O minus combines with OH, and I'll get corresponding tertiary alcohol. This is the strategy is to prepare tertiary alcohols by 1, 1 CC disconnection approach. We can also do 1, 2 CC disconnection in case of the secondary alcohols. This is a secondary alcohol. I break at the CC junction. This gains my electron richness and it acts as a donor synthon. The another part over here acts as an acceptor synthon. For getting this donor synthon, I use an Grignard reagent. And here this is the positive center. This is electron rich oxygen. This is donated to this deficient center and I'll get an epoxide. I treat alkyl magnesium halide with epoxide. I'll get a secondary alcohol. R minus attacks on the positive center. The opening takes place and this becomes OH. And I'll get a corresponding secondary alcohol. This is the strategy followed to prepare secondary alcohols by 1, 2 CC disconnection. There's another example where we see 1, 2 CC disconnection leading to ketones. Here the functional group is alcohol if it is a ketone. At the second position, I break upon, and when I break upon, I'll get R plus as the acceptor synthon and this as a donor synthon. To get this donor synthon, I'll use R1COMe, acceptor synthon Br. This can dissociate in R plus, Br minus, R1 COMe, CH3. If I treat with a strong base, as adjacently it is having carbonyl group which pulls electrons, rendering this methyl carbon electron deficient, and that's why makes it acidic enough to lose the proton. I squeeze a strong base, it abstracts the proton, giving rise to CH2 minus. CH2 minus combines with R plus, I'll get corresponding ketone. If I can also prepare the secondary alcohol in which the alkyl group is present at the third position to this alcohol. 1, 2, 3. I do 1,3 cc disconnection. R minus is the donor synthon and the remaining part will be an acceptor synthon. To get this acceptor synthon, I'll add a double bond over here, R MgBr, and treat with alpha beta unsaturated ketone. It can undergo Michael addition to give rise to corresponding alcohol by 1,3 cc disconnection. I am going to explain this disconnections by using few more examples. First part is one group CC disconnection leading to alcohols. Here at one position it has a functional group, and the same one position we have two groups attached to it. A break up, do CC disconnection over here and CC disconnection over here. Once I do over here, I'll get corresponding carbonyl ester and treat with methyl magnesium bromide, two equivalents. Me minus attacks on carbonyl carbon and ethoxy gets kicked off. I'll get corresponding MeCO. Again, another methyl magnesium bromide, Me minus, it gives attack on this carbonyl carbon and pi electrons moves on to oxygen and becomes OH. I'll get corresponding 1,1 alcohol. I give an example of pirindol or pirindol. This pirindol is a muscle relaxant. The structure of pirindol is like this. It has an alcoholic group. To this, it is attached two phenyl groups. I do one disconnection. One part will be the corresponding ester. I'll do the 1, 1, 2, 3. At third position, there is a piperidine ring. I break at I do CX disconnection, 1,3 CX disconnection. One of the reagent will be piperidine. Another reagent will be alpha beta unsaturated ester. This attacks on this, undergo Michael addition to give this molecule and treat with phenyl magnesium bromide. This gets converted into corresponding alcohol and pirindol is synthesized. I use 1,1 cc disconnection to prepare corresponding alcohol. 1,1 cc disconnection leading to carboxylic acids. Here we have seen the alcohol formation by 1,1 cc disconnection. Let us see formation of carboxylic acid by using 1,1 cc disconnection. 1, 2, 3, 4, 5. Pentanoic acid, OH. I break CC bond over here. Once I break over, this part will become electron rich, minus, act as a donor synthon. To get this donor synthon, I use corresponding butyl magnesium bromide And another part is COOH. To get COOH, I use carbon dioxide as the reagent. This is butyl ion, butyl anion to be specific, attacks on the carbonyl carbon of the carbon dioxide and gets carboxylic acid. Or instead of butyl magnesium bromide, I can take corresponding butyl cyanide. And butyl cyanide, if I take and hydrolyze this cyanide group, CN group gets hydrolyzed in the presence of concentrated sulfuric acid. It gets converted into COH. This is another strategy which we use. The synthon, if it is COH, I can use CO2 or I can also use sodium cyanide. Right? I'll take butyl bromide, treat with sodium cyanide, and get butyl cyanide. Butyl cyanide, I hydrolyze in the presence of concentrated sulfuric acid, I'll get corresponding pentanoic acid. Another one, CC disconnection approach leading to carbonyl compound as the target compound. When I have R1COR2, here I do 1 comma 1 disconnection over here. I'll get one donor synthon R2 minus another acceptor synthon. This acceptor synthon I'll take RCOCl and treat with corresponding alkyl magnesium halide. R2 attaches on this, Cl gets kicked off, I'll get corresponding ketone. 1 comma 2 carbon carbon disconnection leading to carboxylic acid. An example I can give like this is a carboxylic acid. At second position there is a alkyl group and first position carboxylic group. I do disconnection at this position 1 2 disconnection to get this product 1 2 3 4 butane. I'll take 2 bromobutane. Another part is CH2COOH. This is a donor synthon. To get this, I use diethyl malonate. I treat with a base. This is acidic enough to lose the proton as it is flanked between two carbonyl groups, giving rise to carbon ion CHCOOET twice. CH minus attacks on the 2 bromobutane and I'll get corresponding diethyl derivative. Hydrolyze this, ethyl ester group gets hydrolyzed, decarboxylate COH loses as carbon dioxide and I get this molecule. Another example, 1 2 disconnection I do. One part is the acceptor synthon, another part is the donor synthon. To get this acceptor synthon, I will add an electron withdrawing group, alpha beta unsaturated halide and ethyl acetoacetate. It abstracts the proton in the presence of a base minus attacks on this positive center. Br gets kicked off. I'll get this molecule. 1 comma 2 disconnection leading to alcohols. I have corresponding alcohol. I'll break over here. 1 2 disconnection. pH minus donor synthon. This is acceptor synthon. To get this acceptor synthon, this is positive center, this is electron rich. This combines with this epoxide. Epoxide I treat with phenyl magnesium halide. Ring opening takes place and get the corresponding alcohol. Another example I can give over here. CC disconnection. One is donor synthon, another is acceptor synthon. This can form an epoxide. This epoxide reacts with corresponding bromo derivative. I do fragment group interconversion to synthesize this molecule. One part will be one disconnection. One part will be propyl magnesium bromide. Another part will be corresponding aldehyde. These two reacts to give the molecule. I do fragment interconversion by treatment with potassium bromide. Bromination occurs. Treat with epoxide. I'll get corresponding molecule. Next class we'll be dealing with other disconnections approach. Till then, have a nice day. Thank you.